Okay, this is clutch number 018905. You see we had it up to, we had it a little over 180 degrees. We got the heat gun blowing some heat around the back, and we got Mr. Heater here blasting it from the front. We just turned that off to begin the slow cool down. We slowly heat it up as well as slowly cool it down to not shock the unit. We're treating it just like it would be treated in the bus. Right now we are running on high speed. As you can see, the output is rotating and the input is rotating. Just for verification there, we got a non-contact tachometer here running close to 900 RPM with the current gear ratio from our cool pump motor there. Okay, so what we want to show here, first of all, is that, let me dim this down a little bit. We have good threads. Okay. Good case. We have good sealing. There's no seeping, there's no leaking. There's not even any sweating. Okay, we have a good connector. There's our oil serial. Checking the whole thing around. No seepage, no leakage whatsoever. It's very important that I demonstrate this. Obviously the bottom threads are good because that's what's holding it down to the test bench here currently. Okay, you can see everything is torque sealed. It's very carefully rebuilt. Alright, so moving on to the electrical portion here. Alright, so we are running at 26 volts. You can see that we are pulling about 1.6 amps in a hot state of 179 degrees. 41.54 watts. Okay, now we're going to switch over to low speed. Let me move this out of the way so you guys can see. You see the amperage draw drops, and we've got 6.26 amps, or I'm sorry, 0.626 or 625. We've got 16.22 watts. Okay, now let's watch it actuate. Okay, so we're gonna flip this to off, and the all-important off, where this stops, very important. Most fan clutches, this is where they fail, and guess what happens? You end up with after-treatment issues because you're overcooling. And yes, overcooling can happen on a Prevost. So pay attention to that. If you spin the fan blade by hand like so, and you feel magnetism, okay, that's gonna mean that you have a failing fan clutch. You need to replace that as soon as possible. All right, so let's go to low. And if you look inside carefully, you might even be able to see it actuate. There's low, off, low, off. Okay, let's go to low again. And let's switch over to high. And you see it does so seamlessly. Back to low, back to high, back to off. Alright, now we're going to give it its slow cool down. But before we do that, while it's off, we're going to go under and we're going to take a good look at the electrical connector. You can see we use the same connector as the bus. Careful with it. We just want to document its condition because a lot of times this is what the mechanics will damage, and then we'll hear things like, well, it came that way, and these are hard to get, so we have to document their condition, that they are in fact okay, not cracked, not corroded. Everything is good to go with these. All right, otherwise it wouldn't be on one of our clutches. So also, let's take a look at how they spin down. Let's shut the motor off. And there we go. Nice clean spin down. That click you hear is out of this all the way. As you can see, very nice clean operation. All right, let's fire it back up. Okay, and we're gonna let it do its cool down now. And pack it up very securely. Okay, we're connected. Going back to high. And there we are. and you can see that it's stable. That's very important, that it's stable. Okay. Actually, one other electrical test we can do. We perform this test cold, but we'll go ahead and do it hot to show the difference as well. We got about 38 and 13 on the ohm readings. So we'll go ahead and turn this off, and we'll make sure everything's off here because you can't have power when you're ohming, right? And this is all set up to ohm already. You see the negative lead here, positive lead there. That's your high speed coil. So about 16 ohms, which is normal. You can check out any of our other videos on there if you want to compare these readings. And just under about 41, 42 ohms. Like I said, 38 is what we got here cold, and then 13 is what we got here cold. Obviously, as heat increases, it's harder to get electrical flow through the wiring, so the resistance will increase proportionately, and that's what we're looking for, is that it increases proportionately when hot, and that the readings remain stable. That's very important. So let's shut this off. Let's turn our output back on. And let's go ahead and turn the power back on. Go to low to get it spinning, and then up in the high. All right, so now we're gonna let it start its slow cool down. It'll probably take about 15 to 20 minutes so that we don't shock the unit. And then at that point, we're gonna go ahead and go over here, and we're going to pack it up with the oil and a bunch of bubble wrap like this. So it'll be packed to the top with bubble wrap, and the lid will be screwed down. So this thing is very secure underneath this cardboard and bubble wrap as well. So this is how they will arrive, okay? And we'll email you the instructions, and just put your core back in here when you're done and ship it right back to us. All right, thank you guys for watching, and thanks for purchasing. Have a great day.